You're welcome to our website. Today's topic is integration, part 1. Okay, let us look at our specific objective for this topic. At the end, you are expected to know the definition of integration, know the standard integral forms, basic foundation in integration, integration by algebraic substitution. Definition of integration. If you can recall back to your memory, you were told that integration is the opposite of differentiation, antiderivative. The symbol used for integration maybe f of x, the x, the antiderivative. But for derivative function, which is differentiation, you know that the y all over the x will give you your solution. Or this time around, we are thinking about the opposite of this particular differentiation, which is known as what? Integration, antiderivatives. Basic foundation in integration. Before you venture into a large problem, look at what you need to know about an integration. First of all, you've seen the symbol. Some of you may be thinking it is an S symbol. No, it's just looking like S, but not perfectly X. Number one, look at formula ax raised to the power n. When you integrate this, it's going to give us axn plus 1 all over n plus 1. Or you can have x raised to the power n plus 1 divided by what? N plus 1. Using this particular formula is when the coefficient of your variable is greater than 1. That's when you attach a. But when the coefficient is just unity, you are going to use this. But however, it's just a quick source for your what? Solution, knowing if you can actually get the exact solution or what you have as your solution is perfectly correct. That's the reason for this symbol or the formula you are seeing here. Okay, let's take for instance, if you are having evaluate integral of x squared dx, thinking about the formula I just wrote there some minutes ago, n x power n plus 1 all over n plus 1 implies that what is your power here is 2. That 2 is representing this n you are seeing here, okay? The n. X raised to the power 2 plus 1 divided by what? N. What is the n? The n is the power, which is 2 plus 1. At the end, because you don't have any value here and here, you're going to say plus c, or you say plus k, which is a constant. Now, your final solution here will give you what? This x power 3 all over 3 plus c or plus k, as the case may be. Now, let us look at this sample 1. Evaluate integral of, opening bracket 2s plus 1, closing it, raised to the power 5 ds. This question, if you are looking at it, you are seeing power. If it is to be differentiation, this is just what you call chain rule or function of function. Because of what? The power you are seeing there, meaning you are going to let something here. If you let u equals 2x plus 1, it means you are dealing with the one in the bracket. Then the other one will be what? Y equals u power 5. That's another statement. Okay, how do you do it? You are going to settle it one after the other. From here, you can see that the u all over the x equals 2. You are differentiating here, because differentiation of a constant is what? 0. For that of 2s is what? 2. How? Look at the general formula, n into s raised to power n minus 1. The power here is what? 1, all right? Okay, the coefficient is greater than 1, therefore use a n x n raised to power n minus 1, where 2 represents the a. Now the n is the power, 2 times the power, x is coming down, n is 1 minus 1, meaning 2 times 1 times s power 0 to give us what? 2 times 1 times 1. In indices, anything raised to power 0 is what? 1, which will produce 2. So when you differentiate this, this is what you have. Okay, having seen that, let us bring this into our solution. You're going to see that the u equals to the x. Now make the s subject of the formula. You're going to have that the x equals the u all over 2. In the integration we are having here, remember it is what? Integral of 2x plus 1 all raised to power 5 ds. Recall that you have x ds to be what? Du all over 2. And also know that u equals what? 2x plus 1. Therefore, the whole of this place becomes what? U power 5 multiplied by the s. What is the s? Go back here. The s equals what? The u all over 2. Meaning the u all over 2. We are no longer seeing the s again. Now, to conclude your solution, this is a constant which will give us, let's factor out the fraction, which is 1 over 2, integral of u power 5 du. You are going to integrate here. It's just the sentence as when I say integrate x squared, because I know most people, whenever they see another alphabet which is no longer s or y, they begin to think of another thing. U is just the same thing, you are talking to s. The way you integrate s, also integrate u the same way. Now, using the formula I gave to you, x power n plus 1 all over n plus 1. Remember to introduce your constant, that's c or k, anyone you prefer. So, this will give us 1 all over 2 into, if I integrate u power 5 plus 1, 5 is the n plus 1 is there in the original question we have. N is 5 plus 1. Now plus your constant. So this will give us what? 1 over 2 into u power 6 all over 6 plus the constant. Finalizing our solution here, I'm bringing it up here. Recall that. What are you recalling? Recall u equals what? U equals 2x plus 1. That's all. So you have to conclude what you have as a solution. 1 over 2 into 2x plus 1 raised to power 6 all over 6 plus who? Constant. If you want to leave your solution this way, fine, no problem. But if you don't want, just say 2x plus 1 raised to power 6 all over 12 plus c. It will give you the final solution. Now, you may also be surprised in some integration, there are solutions written without the constant. The reason for that is what? Whenever you have ranges of values of s or y here, the lower one and the upper one, that is the time you have to introduce such. When we get to that kind of integration, you would know it. Okay, look at another sample here. Evaluate x dot exponent s squared ds. Okay, this another one that is somehow boring, but not much if you have a proper foundation. It will go this way: integral s exponent ds. What you're going to do here, let u equals s squared, then you also let y equals exponent u. The first thing you have to do, du all over the s equals what? 2x. If you use differentiation formula, you will get that ns power n minus 1, the power into s, 2 minus 1, to give us what? 2x power 1. In indices, anything raised to power 1 remains that, meaning 2s. So this is it. The y, the u, though you don't need this, implies you get the same thing, exponent u. Our major target here is this. So leave this gentleman alone first. So what you have, you're going to say the u equals 2x ds, so that you can make the s subject of the formula, leaving us with who? The u all over 2x. So this is what you have. You are going back to the integration given to you by saying x multiplied by this exponent u dot the u all over 2x, because the s has taken the position of this. So what do you have now? This will give you, look at s here, see x here. What is remaining? Factor out the constant. It will leave us with who? Exponent u, the u. When you integrate, it will give you a solution. Other solution, exponent, you remember what we call len. That's 1 over 2 len u plus the constant, because there is no value given here. So what do you have now? 1 all over 2 len u. What is u? You go back. X squared plus who? K. And again, most people always ask if is there any difference between len and logarithm? It depends on your choice. If you want to use log to represent this, it now means log exponent whatever you have. It will not replace this. Okay. We are having another one, sample 3, integral of cos 5x dx. Take it 1 hour to go. Integral of cos 5x ds. As usual, let u equals to 5x. From your differentiation, you know that y is going to be who? Cos u, but this is not what we are dealing with. So our concern is here. So du all over the x equals what? 5. The x equals du all over 5. I think I'm not trying to confuse you here because we have done this type of thing before. When you cross multiply, you have 5, the s equals the u. Now making the s subject of the formula becomes the u all over what? 5. Now introduce what you have into the question given to us. Cos u multiplied by the s. What is the s? The u all over 5. Okay. Now we're going to factor out the fraction. What is the fraction there? 1 all over 5 integral of cos u du. This is going to give us 1 all over 5. If we integrate cos s, it will give us sin s. This is sin u plus constant. You also recall that u equals what? 5x, meaning our solution is what? 1 over 5 sine 5s plus the constant. Plus the constant. Okay, we are still having another one here. Evaluate s squared, open bracket, 3 plus s cubed, close the bracket, all raised to power 2. The knowledge we have from what we have been doing so far is going to help in solving this problem. So, I will have that x squared into 3 plus s cubed raised to power 1 over 2 dx. There's not much problem here. All you got to do, just say let u equals 3 plus s cubed. You differentiate. The u dx equals 3s squared. Okay? Now, the u equals 3s squared ds. Making the s subject of the formula, that's meaning dividing through by 3x squared. The s now equals what? The u all over 3s squared. Good. Now you can bring it into what is given to us. Dot. Recall, you called here what? U, meaning u power half dot ds. What is ds? Du all over 3s squared. Now it's du all over 3s squared. Gently cancel this against this. You can see it's free now. So what do you have? Factor the constant into u power half the u. The next business here is what? Integrating u power half. Recall that x power n plus 1 all over n plus 1 will settle this guy. So how do you do it? The power there is what? The power is half, meaning x half plus 1 divided by what? 1 over 2 plus 1. Then plus the constant. If you have this 1 all over 3 into x power 3 all over 2 all over 3 all over 2 plus constant. We're going to have 1 all over 3 into, if you turn this, or you want to handle it by saying, okay, let's just believe it's a primary mass you hand. Let's say 3 all over 2 all over 1 multiplied by what? 2 all over 3 into this plus the constant. Let's finalize our solution here. We're going to have 2s power 3 over 2 divided by what? 3 multiplied by 3 plus the constant. So what is the final answer here? 2 into this all over 9 plus constant. Okay, final answer. 2x raised to power 3 all over 2 divided by what? 9 plus c. That is the solution to that question. Okay, let's take some questions from our exam guide. Okay, look at this. Given that ds dy equals root x, find y. This is an applied question because what we know about the s dy is what? Differentiation. But remember one thing from the definition of integration, we said it's what? Antiderivative, isn't it? That's what it is. Okay. Now, we are going to see what it look like. If dy ds equals root x, now find y. Remember from indices, this gentleman simply imply, root s implies what? S raised to power half. Okay? Now, if we are to get the value of y, simply means we integrate both sides. Just like when you are solving your change of subject formula, say, taking the square root of both sides, or squaring both sides, now taking the integral of both sides. All up on here. We'll have that from here, dy equals what? Root s dx, okay? So, integrating both sides will give us this. Let me just write s power half ds. So here now, y equals, now let us get the solution for y. This x power half ds. Okay, no need of letting. Let's use our formula direct. S power n plus 1 all over n plus 1 implies x. What is the n? 1 all over 2 plus 1 divided by half plus 1 plus c. Let's finalize. This will give us s raised to power 1 over 2 plus 1 over 1 divided by 1 over 2 plus 1 over 1 plus c. We'll have that s raised to power, the LCM is 2. This here, this is 1 plus 2 divided by 1 plus 2 plus c. It will give us s power 3 all over 2 divided by 3 all over 2 plus c. So, if you take switching division towards multiplication, something will happen, meaning 2x raised to power 3 all over 2 divided by what? 3 plus constant. That will give the solution to what you have. Okay. You check your option. We have 2x raised to power 3 over 2 all over 3 plus c. Okay, that is the solution for that question. This is a similar question. Let's take another form of this. Okay, this one has range. Evaluate integral of integral 3 minus 2 the uppercase and the lowercase 4x cubed no sign here. Okay, s is plus 6 plus 6s squared minus 7 ds. Okay, let us use plus sign, the operator as plus, to handle the question. If this is given, look at what we do. Can you see this? How many things are here? The number one thing you should know, integration of a constant is what? That constant multiplied by the variable given in that integration. You are seeing the s. See a constant, meaning 7 times s. If it is differentiation, constant is what? 0. Now let's face this question. If you want to help yourself, you can simplify this by saying integral of this minus 2 plus, you are just separating. But you can still solve together anyway. Minus 7 or the what? The s. Okay. Now, if you remember the formula we'll be using, s power n plus 1 all over n plus 1, this will give us what? We're going to have 4s3 plus 1 all over 3 plus 1 plus, let's deal with this, 6x2 plus 1 all over 2 plus 1. Integration of a constant is that number or the constant multiplied by the variable given. Then you will introduce what we call range. What is the range? The uppercase and the lower case. This is 3, this is minus 2. Here, the solution is going to be, let me use bracket to guide them. It's going to be uppercase minus lower case. Now let us handle our uppercase. What is the uppercase here? It's 3. But let us settle this first. If we further simplify this, we're going to have this all over this plus 6s power 3 all over 3. If we cancel, this is 2 minus 7s. Range 3 minus 2. Look at what you are to handle now. This s power 4 plus 2s cubed minus 7. Because I know most of you don't like seeing big numbers. So let us reduce it so that it will be easier to handle. So I want to handle uppercase. So what's the uppercase? 3, meaning x equals 3 at the upper bound. Substitute 3 raised to power 4 plus 2 raised to, that is 2 into s. What is your s? Okay, to finalize this solution, we have to produce a solution for uppercase and the lowercase. Let us provide a solution for uppercase when s is 3, which is the uppercase. 3 power 4 plus 2 bracket 3 raised to power 3 minus 7 into 3. Remember the formula, uppercase minus lowercase. I will now have to introduce minus bracket lowercase. Let's settle this so that we can count for this. 3 power 4 is what? 81 plus 3 power 3 is 27 times 2. That's 54 minus 21 minus our lower case. 81 plus 54 is going to give us 135 minus 21. That is 114 minus lower case. What's the lowercase? Minus 2. Let us handle that of lowercase. We are done with uppercase. Lowercase. You are using the same thing you have, okay? Implies minus 2 raised to the power 4 plus 2 into minus 2 power 3 minus 7 into minus 2. This will give us, there's one thing you need to know. Whenever a negative number is raised to power of even number, your solution will be what? Positive. So don't bother yourself. Even if it is raised to power 16, all you should know is what? Positive. Therefore, minus 2 raised to power 4 equals what? 16, positive, okay? Raised to odd number, it will produce what? A negative, meaning plus 2 minus 8 plus 14. This will give us 16 minus 16 plus 14. 16 minus 16 off, that is 14. Our lowercase is what? 14. Recall that we agreed it is what? Uppercase minus lowercase. So what do we do? The uppercase minus the lowercase, that is 114 minus 14 equals what? 100. So 100 is the solution, is the answer to that question. You can see there 100. Okay, actually this operator here is plus. Okay, this is just a similar thing, okay? But to have an unknown value in it. If integral of 3, 0, open a bracket, ps squared plus 16 ds equals 129. Find the value of what? P. We are interested in the value of P, so integral of, this is 3, 0, ps squared plus 16 ds equals 129. You don't need to be afraid about this. It just, that's when this is being integrated, it will give us what? 129. That's what they mean. Now find P. Okay, look at how we're going to do it. Since our interest is P, taking this as a case study, we'll have that ps squared. Recall a x n plus 1 all over this. This still remember? Okay. Where a is representing who? Because I know most of you, your fear now is what? The p you see. You don't like seeing unknown. So a has taken the position of p, meaning I write p into who? X. What is the power? 2 plus 1 all over what? 2 plus 1. This will give us what? Px cube all over this. We have taken care of this place. There's something I told you. Constant is what? The constant multiplied by the what? The variable, meaning that px cube all over 3 plus who? 16x. Range. What is the range? 3, 0 equals to 1, 2, 9. You have settled this case. Now you have this. We'll go back to our formula, uppercase minus lowercase. That is the uppercase here, p into 3 power 3 all over 3 plus 16 into 3 minus, 0 has nothing to offer. So even when you substitute the lowercase, it will still be what? 0. It has nothing to offer. Equals to 129. I think the work is easier for us at this end. So what do we do? You have this 27p all over 3 plus 48. 3 times 6 is 8, carry 1, okay? That is 48 minus 0 equals 129. I can divide this to give me 9p plus 48 equals 129. 9p equals If I subtract 48 from both sides, I will have 129 minus 48. That's 9p equals, this is 81. Dividing through or multiplying through by the inverse or the multiplicative inverse of who? 9p. I will have this times 1 over 9 times who? 1 over 9. P equals what? 9. Therefore, the value of p is 9. We have come to the end of this particular part of the integration. Part 1, you are going to see the type of question you will handle in part 2 of the integration. Thank you for taking your time to go through, but remember to subscribe.